This is exercise 4.7, question 10. Now we've been told that ABCD is a quadrilateral, which is a four-sided shape. We haven't been told that it's a parallelogram, so we can't assume opposite sides are parallel. We can't even assume that opposite sides are equal. So all we know is that it's a four-sided shape, it's a quadrilateral, but we have been told that the diagonals are equal, so that diagonals AC and BD are equal, and that they also bisect each other. Hence they've got the little markings that AP equals PC and that DP equals PB, but all of those four intervals are all equal to each other. Now they've let angle DAP equal alpha and angle PAB equals beta. Now in part A you have to show that angle ADP is also alpha. Now we can see that triangle APD is an isosceles triangle because we have two equal sides. Therefore that's fairly straightforward in that the base angles of the isosceles triangle would be equal, that this angle here at A, so angle DAP is alpha, which is equal to angle ADP, which is also alpha. Reason base angles of isosceles triangle APD, and we also need to say that PA is equal to PD, which is the explanation as to why triangle APD is an isosceles triangle. I'll just put APD in there. Now we can mark that angle in as well. Now similarly we can now look at triangle PAB. We can see we've got two equal sides, that AP equals PB, making that an isosceles triangle. So therefore the base angles of that isosceles triangle are equal as well. So angle PAB is equal to angle PBA, which equals beta. So we can write that up as well. So we've got angle ABP is also equal to beta, because we've got base angles of isosceles triangle APB, and it's an isosceles triangle because PA equals PB, and I'll just mark in the beta on that diagram as well. Now in part B we have to find the value of alpha plus beta. Now when you're asked to do something like this, you either need to look for a straight line or you need to look for a triangle, because we know that the angle sum of a triangle is 180, and quite often this sort of question could also be the angle sum of a straight line. Now we can see that we've got all of the angles in angle ADB. So the angle at A is alpha plus beta, the angle here at B is beta, and the angle here at D is alpha. So if we just outline that triangle ABD, we've got all of the angles in that triangle, and we can write that up now. So we can see that we've got alpha plus beta, which I've got there in brackets, plus beta equals 180. Now we don't really need the brackets here, so we can open the brackets up and we can see that we've got alpha plus alpha, which is 2 alpha, and beta plus beta, which is 2 beta. So therefore 2 alpha plus 2 beta is 180. Now we must put the reason for this, and the reason that alpha plus beta is 180 is that it's the angle sum of triangle ABD. Now you must state which triangle you're working in, because we've got I think we've got 8 triangles, different triangles that could be drawn up from that diagram. So it's very important that you state which triangle you're working in. And hence if we divide through by 2, so if we divide each expression here by 2, so I can just write that out. So divide through by 2. So 2 alpha divided by 2 is alpha, 2 beta divided by 2 is beta, and 180 divided by 2 is 90. We can hence see that alpha plus beta is 90. Now alpha plus beta happens to be angle DAB, and we've been asked to prove that angle DAB is 90. Hence we can now say that, well, angle DAB is alpha plus beta, as we can see in the diagram, because they are the sum of these two adjacent angles. See, angle DAP equals angle PAB, which happens to be angle DAB. So it's the sum of those two adjacent angles. Therefore, we can now say that, well, angle DAB is 90 degrees. Now, in part C, we're asked to explain why ABCD is a rectangle. Now, we have to look at all of the properties that we have. Now, there are 4 tests for parallelograms. And one of the tests for a parallelogram is that the diagonals bisect each other. And we've actually been told that up in the introduction to this question, that the diagonals are equal and bisect each other. So, hence we can say that ABCD is a parallelogram first. So we'll just write that out. So we can say that ABCD is a parallelogram because we've been told that the diagonals bisect each other. Now we also have to explain why ABCD is a rectangle. Now we know that ABCD is a parallelogram, but we know that a rectangle is a parallelogram with one right angle. Hence we have enough information there to explain why it's a rectangle, so we can just put that in. So we can say, but we know that angle DAB equals 90 degrees, which was proven above. Hence, we can now conclude that ABCD is a rectangle because it is a parallelogram with one right angle. And that's the end of the proof.